So I give the floor to Professor Moulas to introduce our keynote. Thank you. It's an honor for me to introduce the first keynote lecture for today. So the keynote, the title of the keynote is "How Does AI Impact Human Behavior? The Interplay Among Research, Design, and Policy Perspectives." This talk was given by Vicky Charisi. It's a great honor that you are with us, Vicky. She's a research scientist at MIT at Singapore and research affiliate at Harvard's Beckman Klein Center. Her work focuses on AI's impact on human development, human rights, and policy in collaboration with industry and international organizations such as the UN, OECD, and IEEE. A former scientific officer at the European Commission, she chairs several advisory boards and has published over 60 papers in the field.
Καλημέρα και από μένα. Ευχαριστώ πάρα πολύ, Professor Moulas, για το introduction. Θα ξεκινήσω στα ελληνικά. Ευχαριστώ πάρα πολύ την Επιτροπή, την Οργανωτική Επιτροπή για την πρόσκληση και κυρίως τη Μαρία Ρούσου για την εισαγωγή σε αυτήν την υπέροχη σε αυτό το υπέροχο community. I will continue in English now. Thank you for bear with me. So thanks to the organizing committee for this invitation. It is a great honor for me to be here in this beautiful island. I'm also, my origins come from a neighboring island here in Syros, so it's the glad is like even bigger. It's just I'm from Mykonos, like just around the corner here. So it took like 25 minutes to come here yesterday. And it is great to see, and I'm really looking forward to see the great work that it is done here at the University of Aegean in Syros and in other islands. So my talk today will be, so as it was mentioned, I am currently at MIT in Singapore. This is a research institute of MIT, the largest research institute of MIT outside Boston. We have a close collaboration with people in Cambridge, in Boston. But the work that I'm going to present today is based on my previous professional activities and collaborations while I was at the European Commission, because I joined this department, my current job, just 2 months ago. I can tell you a little bit about my current projects, but this won't be the focus of this talk. So today I'm going to, the main topic of this talk is to showcase how we connect research, design, and support on policymaking based on research and involving design. So my point with this talk is that when it is really important when we want to have impact to try to connect these three different perspectives. So based on my previous work, I'm going to give some examples where some studies where I have tried to understand human development through scientific research. My main focus is with children. So most of the examples that I will bring here today is based on research with children. Then, based on this research, we contribute to the design of AI applications and robotics, or social robots. So I'm going to give some examples from a design point of view with design methods. And also, based on also my previous experience at the European Commission as a researcher there, working closely to policymakers, I will give some examples on how we supported policymaking based on design and research. So they are all interconnected. And of course, this work is a result of collaboration with multiple institutions in Europe, universities, industry here and worldwide, here in Europe and worldwide. Most of the research was funded mainly by the Honda Research Institute in Japan, and also it's part of the European Commission Joint Research Center. So the main three topics. So first, I will talk about how research and design connect based on some studies we did on child-robot interaction. Then design and policy, the interplay between design and policy. And I will give some examples on how we design the behaviors of this robot, Haru robot, which is being now developed by the Honda Research Institute in Japan and UNICEF, but also with other international organizations. And then also based on research that we did on generative AI and some pedagogical approaches for developing generative AI in education and how this is informing now policymaking. I will start with the first one. Of course, we all have, I see the age group of this community. So probably most of us remember the times when we played outside or we played with our peers without phones or without our computers, right? So this is something that it was like very prominent in the past, but of course still here. But this is changing. So although we used to have collaborative problem solving with our parents or peer collaboration, etc. This, with the use of AI applications, digital applications, or VR applications, etc., this has now been enriched with other modalities. So one of our purposes with this research is to see how different affordances that we have now transforming children's understanding of the world, the children's problem solving, etc. So we conducted, this is research that I did while I was at the University of Twente before joining the European Commission. We tried first to see how children collaborate with each other when they have to solve a problem in a physical environment. My colleagues, I don't have a technical background myself, but I collaborate with computer scientists or people that work in computer vision, etc., or robotics. And we tried to model child engagement through their body posture and through their speech, not necessarily through natural language. So even without understanding their dialogues, their conversations, we tried to model the engagement through these modalities. Of course, this was like a preliminary research in order for us to understand how we can make a robot understand child's engagement while they interact with children. So at that point, we implemented, someone wouldn't tell that this is a social robot. You can see in the picture, this was like just a robotic arm on a mobile basis, where the robot would sort out objects like toys together with children in a kindergarten, and this was in Vienna. So of course, this was a very unstructured environment. Most of you that work on human-computer interaction, you know that unstructured environments come with certain challenges, and especially when you have to also program. So this was like before LLMs. So this is like very important to remember. So my colleagues had to pre-program the robot to respond to certain child behavior or to respond to a certain situation. I just have a question. I have time, like up to what time should I finish? So it's like half an hour more. Okay. Perfect. So it was pretty challenging for us to understand. So we had natural interaction with children, but it was really challenging to understand the details, especially when we were designing the robot. It was challenging to see the different elements of the modalities that we had to introduce there. So as our next step, what we did is to introduce a more controlled environment. So we thought to use a very well-established cognitive task, the Tower of Hanoi, which has concrete steps, a kind of algorithm to solve. And we used this robot that I have there in the picture. This is the Haru robot, again, the robot that I have been working the last few years. So the first pilot we did, it was on this problem with one child and the robot. So we tried to see how different type of interaction with the robot, different intervention of the robot would influence the problem solving of the child. So we had two main conditions. One was a turn taking. So the robot would observe the child, and then we had this interaction, first the child and then the robot suggesting. So you can see the robot only could speak. They could not handle the actual game, but the robot would propose the child the next movement in this cognitive task. And we analyzed the log data, so from this interaction. And the second condition was a voluntary interaction. So our hypothesis, based on pedagogical research, is that if children have the space and the time for exploration, eventually they learn more, even if the current time for problem solving might take a little bit longer. And indeed, based on this, so we wanted to have the robot there present, but we let the child ask the help of the robot whenever they wanted to ask. In the end, we evaluated the task in a slightly more difficult version of this task. So this task is incremental in terms of difficulty. So when you add more disks, then it becomes more difficult. So in the end, we had an evaluation phase for both conditions without the robot, and we evaluated the performance of the child. And indeed, we saw that in the condition where the child had the space and the time for exploration and asked the robot only for help whenever it was needed, the child was more able to solve the problem in a better way, had better performance. Then we thought how this would look like if we add one more child. So we have two children together with a robot. One of my main motivation of working with social robots is that we can have this collective interaction between humans and robots, like technology, this digital environment, there is this possibility just for humans to learn from each other. So not necessarily to force an interaction between human and the robot. So we set up this experiment. We had 84 children. In this, we had different conditions in terms of the interventions of the robot. So in terms of their cognitive reliability, which means that the robot, we had a condition where the robot would propose a wrong answer, and we wanted to see how this would elicit, what kind of the behavior would elicit from the children. And also in terms of emotional expression, sometimes in social robotics, we have robots that might be more expressive, more enthusiastic, or we can have a robot where it is like more neutral, it can be seen like as a mere tool. So again, this study was like pre-LLM. So we had to, my colleagues had, based on my input, we had to pre-program, and we created behavior trees. I think most of you are familiar with this technique with different types of human behavior. And we had the robot intervening according to our conditions. So this was a study where we had a series of different interventions. So initially, we wanted to see the predisposition of each child in terms of trust. So there are instruments, well-validated instruments, trust belief questionnaires. So we wanted to have a baseline there. Then we had, in terms of child's trust predisposition, then we had a baseline session without the robot, because we wanted to see the problem-solving capabilities of the children for the specific task. This was like a very, the simplest version of the task. And then we introduced the intervention of the robot. So we had we split the children in these 4 conditions, and we had the robot manipulation. And then we had the robot again present, but it was the evaluation phase. It was only that the children could ask the robot for help whenever they wanted. And this was also one of our measures. You will see help seeking, right? So when the robot would help. So the first finding was when we had a robot that suggested the correct answer, the correct next movement, the whole performance, the current performance was better. And this was expected, right? So if you have a robot that suggests a correct next movement, then you have a better performance, totally expected. When we have, the second finding was that whenever we had the robot suggesting a wrong movement, we had more interaction, child-to-child interaction. From a pedagogical point of view, that was very interesting. So most of the children understood that the robot would suggest probably a wrong answer, and they started to discuss between themselves if they wanted to follow the robot's suggestions or not. From a pedagogical point of view, a psychological point of view, this elicits metacognitive skills for children, and this is an important tool probably for pedagogy in this setting. What worried us pretty, I mean, it was a little bit raised some concerns, was the third finding, where the children, although in the condition where the robot would suggest a wrong answer, still in the evaluation phase where the children would have the option to ask for help or not, still they trusted the robot when they were in need. So for us, this was an indication of overtrust of the technology when the children, in the case when the children were didn't know what exactly to do. These findings inform the, have informed the behavior of this robot that we are designing now. At the moment, we're in the stage where we transfer this local interaction with the robot in a more distributed interaction, where we have different classes around the world developing projects together, and children from different parts of the world that can interact with children of other classes, like from Japan or Brazil or Germany, Spain, etc., through the interaction with the robot. And then I mean, this is something, I don't have findings yet. This is something that we are developing now, and we are trying to see how this interaction could look like when we have a network of classrooms around the world, and children probably collaborate with the help of the robot, but in a more distributed and collective way. So for the second part of my talk is about design and policy. So again, based on this work, a couple of years ago, we had already published some findings from this work. UNICEF invited us to take part in the first ever policy guidance on AI and children. So we came with this report where there are specific guidance when it comes to children's rights, for example, privacy or inclusion, safety, etc. And the most interesting part was that, so here we have the guidance, but at that point we thought, I mean, UNICEF thought that they wanted to have some pilots for their guidance. So they invited also the Honda Research Institute, together with our guidance from the European Commission, to pilot some of the principles that we came up with. So at that point, we thought that we wanted to understand cultural differences when it comes to the design of robots. So we thought to test it with children in Japan and children in Uganda. This was a paper where it was published a couple of years ago at IDC, a short paper with the first findings, where we tried to see how children in these different contexts, the school in Uganda was in a rural area in Uganda, where they didn't have technology at all. And we introduced at that point, it was like just started COVID, so we couldn't go there. So we interacted with videos in Uganda, and we had the teacher in Japan. So it was like kind of a design process, not only about the robot, but also about how we run this study in such a context. And we used the storytelling activities for children to start imagining how a robot could look like in their everyday activities in a school environment. We saw that there are, as expected, there are some differences. Again, this was a small scale study. Now we are running a larger scale study with children from different parts of the world, but that was a first indication for us about how children imagine in this different context the interaction with robots, and what are the challenges that they see, and what it was important for us. It was very interesting for us. It was that children in Japan, they focused mainly on psychological connections with robots, and probably that's something that has to do with the culture in Japan and the acceptance of robots. For there is a tradition there. Probably that was one of the reasons. While in Uganda, they would focus more on material interactions. So they would imagine even robots helping in agriculture activities or this type of things, right? So we saw that there was a difference there. Again, this was a pilot with a small sample, but one of the important studies for us to understand that when we develop these robots for different cultures, it's really important to understand first the culture and the acceptance. And we ran many activities with children at that point in Japan locally on the design of the robot behavior design. And this had an impact apart from the European Commission, the Joint Research Center where we used to work we attracted the attention of IEEE Standards Association. So they invited us to contribute to preliminary work on standards for social robots for children. Also, Lego at some point, it was very much, they were very much interested in how we included children from environments that typically at this point were less were included, but not so much. I mean, especially in the field of human-robot interaction. I looked in the literature. I'm pretty active in this field, and probably I would say 80 or even more percent of the studies they run with children on child-robot interaction, children in developed countries. Of course, there are practical reasons also for this, but for us, it was really important to show that we really need to include typically less represented places. And there were like much more, since then there are many more initiatives on policy for children and AI and social robots, a little bit less, but social robots as well. So after these results, internally at the European Commission, we wanted to see if what we saw from children's input, how this interacts with the input we get from experts, which is something that we expected anyway, because we work all the time with researchers, but also with policymakers. And one of our findings findings was that policymakers were very, very much focused on education. So they focused very much on the solution. So, and education is the solution, which is really important also for us to see that the education is part of their priorities. After these activities, and because of our interaction between research, policy, design, researchers, we thought that what we need is like really transparent procedures, because sometimes when you interact, I mean, I suppose that most of you have experience in this, sometimes we researchers have a kind of a little bit different language than people in industry, for example, or policymakers. So at some point we wanted to, we thought that what we need is a procedure where in a transparent way, people go through this kind of processes, but they follow them. They follow the. I mean, we try to speak their language, but the underlying principles to be the same, right? So, for example, inclusion of children, etc. So we proposed this this framework. Now we call it the policy sandbox. And when we talk about policy here, it's not only policymakers in terms of governments, it's policy inside an institution, right? So for example, the Honda Research Institute, now we are experimenting with this sandbox in terms of child's privacy when we develop social robots for children. The last part of my talk is about research. So the previous one was like more on the design part, right? So this is like about research and policy. And this was one, probably the only one, the only study while I was at the European Commission that actually my hierarchy asked me to run, right? So up to that point, it was me proposing what type of studies we wanted to have in order to anticipate policy, right, in social robots. But this one was top down, and it was when ChatGPT it was like suddenly very popular in schools, etc. And at the European Commission they received many questions from educators on how they need to handle this new technology. That was back in, I mean, you know, November 22 when ChatGPT got so popular, and I received the request in January 23. Of course, it took us almost 8 months to take the ethical approval for this because it was very new technology, but we designed, what we thought with my colleagues is to design an AI tool based on generative, like on ChatGPT, which is pedagogically aligned, and we used the Socratic method. Probably you remember that in early 2023, some places like in New York, they decided to ban ChatGPT from schools, while a couple of months later, I mean, even the same states, they thought, oh, we can't ban it, we need to see how to use it, right? And then a couple of months ago, MIT Media Lab published this paper where with university students, where they show that when students use ChatGPT, then they just, their brain becomes a little bit more lazy, and this created some worries. But last week, I think it was just, or 2 weeks ago, Oxford University announced that they collaborate with OpenAI Edu in order to bring in ChatGPT for students in order to advance the research. And also I heard also here in Greece that there was an announcement about public schools, etc. So you can see that people have worries, but at the same time, they can't ignore this tool. So what we thought at that point, it was that we need to understand how this works inside the classroom. Of course, now there are many studies that show these results. We started with teachers' workshops. We wanted to see how they perceive this tool inside their classrooms. And then we had some hands-on activities with students, co-design activities with students. And then we also ran a larger scale study with parents' views on the use of generative AI in education. So we had, this was a pilot study in Spain and in Belgium, in Brussels, with 122 students. This is not published yet, it's under review, and we expect that it will be published in the next few months. And we wanted to see first the perspectives of students, and then what would be the effect if we design a tool with the Socratic pedagogical method, what would be this effect. So this is how it would look like. So the LLM wouldn't give an answer to a question, but would follow up with a guiding question. And unfortunately, I mean, when we thought about this, to be honest, I thought that this is a great opportunity, each child to have their personal Socrates with them all the time. Imagine, I mean, this would be amazing. But no, unfortunately, the students didn't like it. So they thought that, when I use this type of tool, I just want the answer. I don't want the question. I just want, as fast as possible, an answer. And what we saw also, it was that so we had several tasks with the use of LLM, and then we removed the LLM and we gave the students similar tasks. If they had used the tool in a certain way, we thought that this would have a positive impact on their learning, reasoning, even if we changed slightly the task. Unfortunately, we saw that there was no retention of knowledge, which means that the students didn't, in fact, engaged in-depth conversations, and they didn't, so they focused mainly on the answer of the specific task without paying attention on the reasoning. So for this, I think we need to revise so we are working on this. And one of our explanations is that this was only one session. So we had one session engagement with the specific design, and then we proceeded with the evaluation phase. So still, I have some hopes that this can be used in a way that would support the children's critical thinking in the future if there is a longer term interaction. But what we did also, it was to see if we don't have a Socratic method, so not to have these guiding questions, but instead having an answer with an explanation, how a very specific explanation, how this would work. And here we found some promising results. So the students, when we removed the LLM, they had a better performance than the Socratic. So probably the more explicit explanation worked better in this setting. So these are the main findings. And then what we wanted also to see, it was parents. So how parents behaving on this, because often I am a parent as well. And sometimes I don't really know what my children do with ChatGPT when they use it for their homework, right? So, and indeed, this is something that it was apparent also. So the first finding, it was that parents that use the LLMs for their own work, they have a more positive attitude towards the use of LLM in education. So in different aspects. So this was a pretty consistent result. On the other hand, we saw we saw that almost half of the parents, they don't know what children, they don't talk with their children. We focused only on teenagers, right? So from, I think, 12 to 18 years old students. So they do not discuss with their with their children, but at the same time, they have some concerns. So this was a work together with the United Nations Center for AI and Robotics in the Netherlands. And we thought that based on this, probably we can publish a guidance for AI literacy for parents. And we have certain recommendations for parents on how to handle this on AI literacy. So with this slide, I'm closing my presentation. And what I wanted again to stress is that although I think in this room most of us are researchers, it is really important to consider the policy context, but also how industry proceeds with the development of AI tools, social robotics for children or for people in general. My personal view is that we need to make sure that all citizens know about this, and we provide the opportunity for AI literacy for everyone, not only for children. And this interplay, I know, I'm aware from that many of you try to see this interplay, but I wanted with this talk to highlight the interplay between policy, industry development, and research, and how they inform each other. Thank you very much.
Okay, thank you, Vicky, so much. First of all, for coming here, for your fascinating body of work, which I know. So I know about that, but yet again, when seeing this presentation, it reminds me of how wonderful your work is, and I really love the questions that you're asking and the approaches that you have. So I have many questions, comments, but let me start with, I have two that stand out, two aspects of your work. Let me start, first of all, I'd like to ask you how you compare the work with social robots, with robots that have a physical presence, a tangible presence, and chatbots, and their impact on children's, let's say, social interaction, but also perception. There's a difference in the interface, and there's a difference in the interaction method as well. So you have a Socratic method that you used, which I have some comments on that as well, or questions. But can you compare the difference? Because you have very different results. In one case, you have engagement, you have reliance. When they're not confident about their knowledge, they rely on the robot's needs. Whereas in the other case, they want direct answers. Right? So do you think that the interface and the interaction method has in that case means something?
Yeah, thank you for the question, Maria. This is a really important element that I'm pretty sure you know the answer. So indeed, the interface plays a huge role. Again, I want to highlight that this presentation was like pre-LLM and post-LLM. So there is also, so the in the interactions that we did with robots, we didn't use LLMs for this study. So that means that anyway, we had to focus probably in other aspects. So, for example, and of course, the interface elicits certain probably trust levels for the students, or eliciting more engagement, etc., especially for young children, where even that robot that I showed in the beginning of my presentation, which was like just a robotic arm with on the mobile robot like base without a shell, and still after the interaction, so it was like clearly a machine. We asked the students if they would how they would perceive the robot, and most of them, it was like, this is my friend, I would tell all my secrets here and not to my mom, right? So no, I'm talking for the very first where we have just a robotic arm, right? So the arm, so it was like clearly a machine, but even that, just because of the physical presence, elicits, as you said, like we attribute anthropomorphic feature into that machine, which might be different when we have a screen-based, text-based interface, right? This is changing. First of all, I haven't done experimental research to compare the two, right? So I cannot tell based on results, but there are other studies. Yeah, there are, I mean, people have studied this. I know probably Panos, I think. So we have in the literature, there are studies where they compare the physical presence of the physical embodiment with virtual embodiment, that we do have a difference there. On the other hand, now with the use of LLMs, I know that people try to also develop more advanced chatbots and also more advanced robots for children, right? So for people. So these things will change, and pretty soon. And I mean, we experiment with this a lot. Again, I'm not entirely sure how these would impact the interaction in the future. And probably even if we have a robot, students in high schools inside the classroom for school-based activities, still they would want just a quick answer. This I cannot tell. We don't have at the moment this type of research, but we are observing a shift in terms of interaction with digital tools. I think in a more general way, and I think this is not only about interactions with digital tools, but sometimes interactions with humans as well.
Thank you, Vicky. I'm Nikos Savouris from University of Patras. Thank you for this interesting talk. I have various concerns relating to your research, and I think a conference is a good point to start talking about it. Now, working with children is really a great responsibility for us researchers. And especially in the context you presented, social robotics, which I should say that's from the beginning, I'm totally against. I think it's a really bad idea, but anyway, but okay, I understand that as researchers, we need to explore interaction with them, with young children, and the impact it may have in their learning, in the behavior, etc. But I'm always questioning, and as I get older, become more and more critical to the point of view our research community, our researchers, towards the industry and the typical users. Now, you're doing research funded partly by Honda, who is their invested interest is to develop their, like Haro or other robots. They're famous for their great work, by the way. So their interest is to promote their the products. And you go to countries like Uganda, which I don't know exactly the context of that particular school, but social robots, which is a typical technology of the global north, let's say, goes to global south to make an intervention there. And I will report my experience, because I've been working with learning technology for many years. When we went to, in this country, which probably we are more to the north than the south. We're in the border, basically, where people were saying, okay, we like your technologies, but the roof is leaking. So the priorities of that particular context were, and made me really feel very bad about it. And probably, I don't know the details of the Uganda experience, but it's an interesting point. And I'll come to the, I make reference to UNESCO recommendations for working with technologies, especially with children. And they refer, between many other things about privacy, etc., on the proportionality and do not harm. They always say that evaluate the risk-benefit balance. So for social robotics, do we evaluate whether it's better to have real human collaboration, better conditions, better teachers to which they communicate than interacting with this social robot? And have you questioned this and put it that in perspective as with the ethical responsibility of you as researchers towards this this context, this situation, this research? This is just some thoughts.
Thank you so much for giving me the opportunity to reflect on these mainly 3 points. And these, I can assure you that these are questions that I have all the time. I will start with the first one, which is, so the first one was about we do research with children, and we do research. Indeed, it is funded by Honda Research Institute. The main reason that I was engaged, so first of all, when I mentioned funding, it is not. I was at that point an employee of the European Commission. I was not allowed to get any money. The European Commission didn't get any money. So there was no money involved. The funding that gets from there, I like funding, it was like they provided the robot, the platform, and they provided the technical support, because the European Commission does not have any technical, I mean, the Joint Research Center, they could not, at that point, I was in Sevilla, we didn't have the capacity to have like technical people running this type of studies, right? So the Honda provided the technical support through the university in Sevilla with roboticists and the platform. So this was their contribution, right? But as you said, they are developing this robot. This is the Honda Research Institute. This is not a product, right? So there might be a product at some point. There might not be a product, like Asimo, for example, never became a product, right? So they're more interested in developing the technology and from my point of view as a researcher, and also as a person that I'm really deeply interested in child development, and I want to put like my little contribution on this the best possible way. I wanted just to explore how people in industry would perceive these restrictions, say, from a policy point of view, or how they would behave if they collaborated with UNICEF and these people. So for me, the interaction between Honda and policy institutions was like the most important part that I wanted to be present and observe. And again, I chose Honda because of course, they are like a profit organization, but for me, it's not one of those institutions with very aggressive behavior. So their values align somehow with mine. So to answer your question about the involvement of Honda, this is the context. I wanted just to give you the context, so it's you have like a little bit. So. But again, this is something that at some point probably develop as a product. So in the second point, which is research in developing countries, I had exactly the same questions for me. So even before I started, I had multiple meetings with the teacher, and I asked exactly the same question to the teacher. I told her, I mean, you don't have floor, you don't have ceiling. Is there any point for us to do it? And the answer, I received 2 answers that are, I mean, still echoing in my ears. First answer was, this technology now is being developed. We want, I translate it in our language, right? I want to be part of the dialogue. And I want my kids also to be part of the dialogue. So I want not for Western children being part of that dialogue, and then at some point they come here with a robot, say like, this is what we are going to use, right? So, and I see this point. Of course, this is a very complex endeavor. I'm not saying that we solve this problem at all, right? But I see that as a starting point, even inside the community of human-robot interaction, to tell, to show to my colleagues, okay, probably we want to start involving other populations, even if at the moment do not seem relevant, or if they have other priorities to solve, right? So, and I gave them the option. So I asked them, they didn't receive money. It was like, volunteer, do you want to participate, etc. The second answer that I got, it was regarding children's experience through this interaction. So the kids had these kids that otherwise they would only interact within their environment, had the opportunity to interact with children in Japan. We had like calls all the time. They discussed, and what happened, it was, I mean, some people would say probably these kids in Uganda would gain something from kids in Japan, but in our case, it was exactly the opposite, because we had the kids in Japan being very introvert in their conversations, etc. So when I started, because initially we had separate calls, right? So not together immediately. So I wanted to have like separate calls from each of them. And in order to start a conversation and to keep a conversation with children in Japan, it was really difficult because they were very introvert. They wouldn't initiate interaction, etc. While it was exactly the opposite with children in Uganda, where everyone wanted to participate. And then through this interaction, the children in Japan started also to communicate. So here we had a positive effect, probably in a different direction that most of the people would expect. And there was one more element that it was a little bit like I didn't expect at all. So the teacher asked me if we could have the sessions on a Saturday, not during the school hours. And I asked her why. And she told me in that case, girls stay less at home, so they have less possibilities to get pregnant. So still I get goosebumps. So although I see your point, these were the reasons that I proceeded with this. The third point was about the, remind me? What was the third one? But I think you get the point, right? So it's inclusion is really important. Oh yeah, I remember the point. I remember. So it was about human-to-human collaboration, human-to-human interaction in schools instead of human and robots, right? So here is, here I will talk about a little bit on my current project at MIT, where we are developing an ontology with 35,000 human occupations. And we are trying to understand the current status of AI replacing humans in jobs, not generally in jobs, because these 35,000 occupations have different tasks, and we have thousands and thousands of tasks where we have either only AI or robotics performing certain tasks, or we have collaboration between humans and robots. So I understand that, of course, human-to-human, especially in the field of education, human-to-human interaction is really important. We want our children to interact with human teachers, right? At the same time, I think all of us observe this rapid development of AI, and people, probably you have heard people predicting the change in occupations that this will be pretty fast. At the same time, we have a large community of, even they have a conference now. I mean, probably not now, but now it's like getting really, really popular. Is the conference of humanoids, right? So they are trying to develop general purpose robots. So given these developments, I believe that what we need to do as a community is also to educate students to be critical, to know how to collaborate with these tools, etc. So again, I wouldn't like to observe as a mother and as a researcher, people getting into their workplace and suddenly they have to collaborate with certain entities that they didn't encounter before. So this is like my main motivation.
Thank you for the great talk. Marios Konstantinidis from Science Center of Excellence in Cyprus. So I wanted to touch on your last point that you said to encourage policy, right? How we influence policy. So I was wondering, from your experience, right, having worked in European Union, now in research institutes, how can we as researchers practically influence policy? I mean, sometimes I reflect on my own papers and the papers that most of us in this room write, right? We write in the discussion, let's bridge this gap between academia, policy, and industry, right? Do you have any practical tips from your experience on how we can reach that level?
Yeah, first of all, this is very difficult. Even being, I was a researcher inside the European Commission, the independent research institute of the European Commission, that the main job was like science for policy, like evidence-based policy support. And still, this was, we as researchers, we did policy recommendations. Many of the times this would be ignored, right? So because there are so many factors around it, financial or political, etc., that, and again, science and scientific evidence is like a little part of it, and etc. So when you're outside the policy institutions, this becomes even more difficult, right? But again, at the moment, I think in the area, especially in the area of AI and digital tools, there are many international organizations. So the European Commission probably, I think many of you probably have already some interactions through the funding that the institution brings. My recommendation is that I acknowledge that this is very difficult. My recommendation is just make it as simple as possible, because policymakers do not read papers. Full stop. Just write like 3 sentences for them, as plain as possible, and this might at some point come to their ears. But yeah, this is my main recommendation, and thank you very much for the question.